Hello everyone. Thank you for joining us as we present our work on Primer, a Honeypot Measures of Effectiveness tool. This work is credited to Kyle Hoffpauir, Nathan Markle, Cameron Meadows, and our mentor, Dr. Jason M. Pittman. As an introduction to our study, I would like to define a honeypot and its purpose. Honeypots are vulnerable computing systems deliberately exposed to the public to attract attackers. The mission of a honeypot is to capture attackers' behaviors so that cybersecurity researchers can analyze the information and develop better defensive technologies. Prior research on honeypots has found there is little quantitative validation of effectiveness. This leaves professionals without the means to know whether a honeypot is effective in its implementation. In our previous research, we developed a taxonomy to model the characteristics of dynamic honeypots that are necessary to serve as specific measures. We now present Primer, a novel software tool to generate identical, realistic usage in target honeypot measures of effectiveness characteristics. In the past, the method for testing the actual effectiveness of a honeypot was to leave the honeypot exposed on a network's perimeter and then record any random attacks and interactions that the system encountered. Our tool Primer was developed with the goal of testing honeypot measures of effectiveness on demand. This is done through the use of pre-recorded PCAP files, which Primer uses to generate activity on the honeypot and store all of the attack information into a log file. We ran an experiment to validate Primer by running 2 separate attacks against a cowrie honeypot and comparing the results to a different cowrie honeypot that was exposed to the internet. We compared the data in terms of both accuracy and volume. Looking at the 2 accuracy diagrams, we can see the diagram on the left shows the traffic on the honeypot that was exposed to the internet for 30 minutes to try and experience an attack, while the diagram on the right shows the controlled attacks using the Primer tool on the honeypot. The only traffic the honeypot is experiencing is that of the PCAP attacks that were used to analyze it. On the volume diagrams below, you can see the difference in the volume of data between the internet honeypot on top and the Primer honeypot on the bottom. The internet-exposed honeypot was receiving constant low-volume traffic with erratic jumps in data. In contrast, the Primer honeypot experienced a controlled burst of data over a short period while the PCAPs were being used before experiencing no further traffic. The main advantage to using the Primer tool is to provide accurate, controlled attacks. Primer also removes the randomness involved in whether or not an internet-exposed honeypot will even be attacked in the first place. Primer also allows for validation for the measures of effectiveness of a honeypot, since you can clearly analyze the attacks performed on the honeypot, as well as the honeypot's reaction to the attack. Primer also outperforms the internet honeypot strategy, as the most packets that the internet honeypot received was 3, with no way to ensure that the attack was even on an open port of the honeypot. Primer, however, allows you to direct the attack to a port that the honeypot currently has open. Honeypots help security professionals and researchers understand how attackers behave. Based on the results of our test, we recommend the following. Use Primer to mathematically analyze the measures of effectiveness of different available honeypots. And, using Primer, test the honeypots being deployed in production environments to ensure expected and actual behavior matches.